Today, I'll be giving a quick demo of my A-level computer science NEA project, which is a 3D strategy game built from scratch using OpenGL and some custom algorithms to generate terrain. I'll walk you through some of the cool features and explain how I built it without using a pre-made game engine. As you can see, the terrain is generated dynamically in 3D. The camera has smooth zoom and panning controls, and you can see the terrain up close or from a more strategic top-down perspective. I've also implemented procedural generation for infinite map variety, meaning no two playthroughs are ever the same. So let's start with one of the key parts of my project, the terrain generation. Instead of using a game engine, I wrote a custom algorithm to create a map filled with different terrain types like grass, water, and mountains. I used Perlin noise to generate smooth, natural-looking landscapes, as well as fractal Brownian motion to add variety and realism to the terrain. Now you might be wondering, what exactly is Perlin noise? Essentially, it's a type of gradient noise, which is often used in procedural generation like terrain or textures. The key thing about Perlin noise is that it produces smooth, continuous, but still random-looking patterns, which is great for generating natural-looking terrain. Unlike pure random noise, Perlin noise has a coherent structure, so the changes in terrain are gradual and not jarring. It works by blending random values smoothly between points, making the terrain look more organic and less artificial. In this project, I used Perlin noise to create the height map of the terrain. The fractal Brownian motion I mentioned earlier helps add complexity by layering multiple levels of Perlin noise, creating more realistic mountains, valleys, and lakes. Another exciting feature of the game is the shader system. I created custom shaders to handle lighting and texture mapping. For instance, here you can see the lighting being applied to the terrain, giving it depth and realism. This was done using the Phong shading lighting model, where light intensity is calculated based on the angle between the surface normal and the light direction. These calculations are performed in the fragment shader. The shaders also handle things like ambient light for softer shadows and specular highlights for reflective surfaces. It really brings the terrain to life, especially when the light source moves across the map. Moving on to the gameplay, I've implemented a simple UI system where we can interact with the animals on the map. Each tile can hold up to 3 animals, and you can move animals between tiles as well as buy new animals as you collect coins. To make the selection process more intuitive, I added some color coding. For example, when an enemy is selected, the corresponding animal's tiles turn red, making it stand out. It's all controlled via custom shaders with different colors indicating various interactions like selection or mouse hover. Now, let's quickly talk about the rendering pipeline. I'm using OpenGL for rendering, and I built the pipeline to handle vertex processing, fragment processing, and texturing. The process starts with loading 3D models and textures, followed by applying shaders to handle lighting, textures, and effects like reflections. Here you can see how the vertex data is processed and how the textures are applied to create the final image. The whole process happens in real time, and it's really satisfying to see the 3D world come together from code. Writing everything from scratch, including the custom shaders and terrain generation, really gave me the chance to dig deep into game development, and I've learned a lot in the process. I hope this gave you a good idea of how my project works, and if you've got any questions or you want to learn more about how I built specific parts of the game, feel free to leave a comment.